Why are you doing that? Hang on a second. All right, well, I'm going to assume it's working. Hopefully it is. All right, on to code here. So you guys are seeing this. And I'm just going to I'm taking these examples like directly from the textbook. So to give you guys as much reinforcement on these as possible. But just to kind of get you into just the idea of normalization and what it means. Basically, I mean, it's a way you could say, if you ask a lot of people, what is data normalization? A lot of people will say, well, it just means, you're getting rid of redundancies. But that's not really accurate. A lot of time what you're doing is you're adding redundancies. And basically what you're trying to do is make the code or the data as flexible as possible. And ultimately what that means is separating out information that's grouped together that shouldn't be necessarily, and making sure that you don't have to change the database table as you go along, as data gets added to it or what have it. To me, those are the two main things. And just to get you started off, an example that the textbook uses is if you've got something like this, where you've got vendor contact, sales contact name, right? So we know about their vendors and invoices and invoice line items and whatever in that BAP database. And let's say you just have a single field for the contact name, which you guys know does not happen. There was a vendor contact first name and a vendor contact last name. So this would be a problem if we had a single field, a single entry for first name and last name, because there are times when you would want to be able to access the last name by itself or the first name by itself, or to reverse the two names with a comma in between, right? Because that's the way alphabetization normally works, is you go by last name, comma, and then space, and then first name. So that's why that would not work as far as normalization goes, and why you would want to avoid something like that. Instead, you would want to have something like this, which is what the database actually uses, which is there's an entry for first name and then another one for last name. And there's a little bit of a typo. That's my fault. There we go. Right, let's have those separate. So now you can do whatever you want to with them, right? You can access them individually, you can rearrange them, you can reconfigure them, whatever, it doesn't matter. Now, some of you programmers out there might think, okay, but fine, if you just give me this string, I can do whatever I want with it, right? I can parse the string, I can split it by the space, I can do whatever I want to with it. Yeah, fine, you can. But you don't want to have to ask other coding team members to do that sort of thing, or whether you want to keep it to a minimum. You really want to be able to access this stuff separately, pretty commonly. And if you do, you want to have separate fields for them. So another example, is, and probably a more serious one, would be like the vendor address. So if you had something like this, where there's a single field for the entire vendor address, then yeah, you would definitely want to split that up the way that they do in the database, so that you've got different fields for the street address, the city, the state, and the zip, because there's a reasonable chance that you're going to want to access one or more of these separately, even if only to print a form that you can then slap on the front of an envelope that has these separated onto different lines, right? Or these concatenated on one line and these, who knows what, right? Point being, you have to have that flexibility, and that's what normalization is really about, is having that flexibility. So normalization, and the somewhat more extensive examples about normalization in chapter 10. There are 7 normal forms. And if you're going to be really serious about database design, and I have had some students who, walked out with their degree and said, yeah, this is what I want to do for a living. Not very many, but some. And, some people just love working with data. And that makes perfect sense. So if you're going to be like seriously going to be a database administrator and a database designer professionally, then yeah, you got to get to know all 7 normal forms. For the purposes of this class, and really for my own work too, it's really just the first 3. The first 3 normal forms are what you usually wind up using and making sure that your data conforms to. So there are definitions in the textbook about exactly what each normal form means. I'm just going to show you the example for each of these. Well, I'll go ahead and mention them. I mean, the first one is the most common one that has to be dealt with, and that is the examples of these guys right up here. These, putting the first and last name into a single field, or putting the entire address into a single field. What this means is that one entry contains a list of data, right? It's not a single data point. This is a single data point, just a single first name. There's no way to break this down any further, or at least any way that would be useful to anybody. This is a single data point. This is really a list of data points. There's a first name and a last name. It's a list, right? This is also a list. There's a street address, there's a city, there's a state, and there's a zip code. So that's a list of 4 data points in the same entry. So first normal form just says, don't do that, right? If you see something that is clearly a list of items that should be able to be accessed and manipulated independently of each other, then they don't belong in the same field. That's basically the first normal form. Now, when you fix that, a lot of times you wind up breaking the second normal form, which is that every column has to depend on a primary key. And, well, I'll show you, examples of that just in a couple of minutes here. The third normal form sounds like the same thing at first, where every data field has to depend only on the primary key. So the way to understand why these are different is to understand that there are actually things called compound keys. And I can't remember if the reading from last semester went into this at all. But let's go ahead and take a look at this really quickly. So I'm going to put in an example from the textbook. This is from page, I think, 325, where it's showing some invoices here. And this is what the table looks like. By the way, I'm giving you a little preview about what Markdown is. I'm putting in Markdown over here, and then it's rendering it over here, basically as an HTML page. But anyway, this would be a very simple invoices table. Now let's say this is before we know that we need a vendors table and an invoice line items table and whatever other tables we have there. Let's just say we start out thinking, oh yeah, all we need is an invoices table because it's got all the information in it, right? It's got the vendor, it's got the invoice number, it's got all the stuff they got bought, that's stored in that particular invoice. So cool, that's all we need. I'm ignoring dates and so on, but still. So here's the problem. This guy right here under the item description, you see where it's got like Android ad, the MySQL ad, and the library directory. So these are 3 things that got bought by Connors Publishing under invoice number blah, 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 right? So you guys already know, if you were just listening to me a couple of minutes ago, you know that this breaks the first normal form. Why? Because it's a list of things. It's not a single data point. It's 3 data points in a list. Android ad is 1. MySQL ad is another. Library directory is a third. So this violates normal form. We got to take that collection or list and break it up somehow. Get it into different fields. Likewise, this one down here. So there's 2 data points here in a list. There's catalogs and MySQL Fire brought by Zilka Design, and then there was another invoice where they just bought one thing. Okay, so this is the example. I think this is the exact example from the book. So we've got to split that up somehow. We've got to break up those collections into their own fields. Just making that a little bit bigger here. So here's like the first thing that you might want to do with it. Hang on a second. I'm copying and pasting from another app here. I'm doing it without a mouse. Okay, there we go. Trackpads. I'll never get used to them. So here's one way that you might be tempted to break this up. Let me put a little splitter there. So you might say, okay, fine, Bispo, whatever. I'll break up this list and I'll put them into different columns. Haha, done. So I will still have the same number of entries, right? I've got 3 invoices here, each with their own vendor name and invoice number. And each one of them simply has another column for each of the entries. So instead of having a list of Android ad, MySQL ad, and library directory, I now have them under 3 columns. And catalogs in MySQL Flyer for the next, okay, cool. And then I just got null for the 3rd entry because they didn't buy a 3rd item. And the 3rd one, I got 2 null entries. Cool, done, right? No, this doesn't work. It may seem like a solution to the first normal form, but it actually is not. This is still breaking first normal form, even though these are not in the same entry anymore. They're basically act like they are. Practically speaking, let's say somebody came along. Let's say Zilka Design came along and bought some other stuff, and this time they bought 4 items instead of just 3. Well, what happens then? Do you have to add another column to your table just to accommodate the 4th item that they bought? What if someone else came along and bought 10 items? Do you then have to do that? Like add all these columns and like automatically add in null values for everybody else now? No, that's the last thing that you want to be doing, right? You do not want to be forced to change your database table, based on some operation from the table or from the user or whatever. So this is not a solution, and in fact, it does not solve the first normal form. It's still breaking first normal form, even though you've got these in separate fields now. And you could theoretically treat these as individual entities, and so it might seem like it solves it. It actually doesn't, because it's not really a solution at all. It flat out doesn't work. And if you can be absolutely certain, like, yeah, no one will ever buy more than 3 things because that's just how our shop is set up, I don't know, maybe then. But I still wouldn't think of this as being the best solution, even in that case. So what do you have to do with it instead? Well, if you can't stack these guys horizontally, that means you have to stack them vertically. So like I was saying before, like people say, like, database normalization is about removing redundancies. Well, it really is not, and sometimes it's about kind of the opposite. It's about like adding redundancies in order to get this data in the best form, the most usable form that it can be in. So what is the solution to this then? Well, as you'll see, I mean, you guys already know what invoices looks like, and so we're starting to get closer to what they actually have in the database as invoices, which is starting to be something like this. Now it's starting to seem like, okay, wait, we got a lot of stuff in here now. This is getting pretty complicated, isn't it? I mean, didn't we start out with this very simple and easy to read thing up here? Well, yeah, the table itself might be visually easy to read, but reading a visual table is not what databases are about. They're about storing data in a way that is, what's the right word? I mean, consumable certainly, and persistent, right? We want persistence of data, and we want, we want to enforce some integrity of our data between tables and so on. So yeah, it is getting more complex. And look at this, we are starting to have to add redundancy, like I was saying, right? But this is starting to work better now. This is good normal form, like first normal form here. So instead of stacking these horizontally, we stack them vertically and have a different entry for each one. Same vendor name, same invoice number, different item description. These 2 here are the same invoice number, same vendor name, different item description, and so on. And there's the 3rd one. So this is compliant with first normal form. So even though you're seeing a lot of redundancy, that's the kind of thing that you start to see. So when you do that, when you solve first normal form, you tend to, not always, but you tend to wind up with a composite key. And let me show you what I mean by that. Let's see, where's my example? Okay, so this is the same thing as the last example that solves and complies with first normal form, but I'm going to, we've added a couple more columns here. And this is really starting to look more like it, right? So we've got an invoice ID, which we should really have. The vendor name and invoice number are the same. We've added an invoice sequence column here, and the item description is the same. So the invoice sequence here says, okay, this is the first thing bought in this invoice. This is the second item in this invoice. This is the third item in the invoice. And then in the next invoice, the 97/522, here's the first and second items. And then the third invoice has only one item. And that is a typo, because if that is the first thing in that invoice, then that should definitely read 1 instead of 2. So let me just, or 3. So let me just fix that. So yeah, items 1, 2, and 3 in the first one, 1 and 2 in the second one, and then the only 1 in the third one. So the second normal form, as we were saying, it states that all items must depend on the primary key. So here's what is meant by that. This table, this current version of the invoices table, has what's called a composite key, which means that there's at least one column that depends on not one other column, but 2 other columns. And let me show you what I mean. So each one of these, the invoice number and the vendor name, depend only on invoice ID. They don't depend on the invoice sequence. But this guy right over here, the item description depends on not only the invoice ID, but also the invoice sequence. Remember, we're saying this is item 1, this is item number 2, and item number 3. Item 1 is, or sorry, Android add is item 1 from invoice 1. MySQL add is item 2 from invoice 1. Library directory, item 3 from invoice 1. Catalogs, item 1 from invoice 2 now. So that's what's meant by a composite key. This column here depends on both of these columns for their ID. It's not just invoice ID, but it's also the invoice sequence for both of those. So the solution here now is to break this into 2 different columns. And if you're thinking about kind of some of the exercises we did last time, you're probably coming up with the answer already. We need an invoice line items table, right? So let's see if that's what I did before here. Yeah. So we wind up with 2 different tables now. We wind up with an invoices table and an invoice line items table. So the first one, invoices table, contains only the stuff. Remember, we were saying this stuff is only dependent on the invoice ID, right? So now, look how much shorter that is. We've got, once again, just 3 columns instead of 6 columns, and it has just the invoice ID, 1, 2, and 3, the vendor name for each, and the invoice number for each. Okay, so that at least is getting simpler again. Hooray! When we take like glommy data like this and start splitting it up into multiple tables, it can be like a breath of fresh air, because that's when you're starting to see the simplification again. After feeling like we were taking something that started out simply and it's getting more and more complicated, then all of a sudden, it's getting less complicated again. We're happy. So there's the invoices table. And let's take a look here. So we now have another table, invoice line items, which has the other stuff in it. Remember, the item description is the one that depended on the composite key, invoice ID and invoice sequence. We put that into its own table here, where we have the invoice ID, invoice sequence, and then the item description, and that's it. So we break this messy business up into 2 different tables, and everything's happy. So that's all well and good. The third normal form, every non-key column has to depend only on the primary key. And so in this case, the vendor info here, we're looking at the invoices table. The invoice line items table we're happy with. That one's good. But the invoices table here, we've got some problems here. The vendor name is not dependent on invoice ID. Only the invoice number is really dependent on the invoice ID. Vendor name needs to go into its own table. So we need to split this table up now, invoices. So let me get another divider there. And so the invoices here, hang on a second. Let's look at invoices first. So invoices here, the stuff that we want to take out is the vendor name here. Connors Publishing and Zilka Design. That's stuff that shouldn't be in the invoices table. So instead, we simply have a vendor ID. Now, it might seem like, okay, yeah, so we've substituted a string for an integer. What's the big deal? But the integer here is referencing the more verbose information in another table, in this case, the vendors table. So here's vendors. So we've taken this business here that has invoice ID, vendor name, and invoice number, and split it up into 2 different tables so that the vendor name information is in one table and only the invoices information is in the invoices table. And more critically, the vendor name only depends on the ID, and that's it, right? Just the same thing as here, except that we've got the extra column that is basically a foreign key that's attaching itself, or referencing rather, the vendors table. So here are our final 3 tables with just the information that we've got here, or just the data structure that we've got. Now, obviously, the ones that are actually used in the textbook exercises, they're obviously a lot bigger than this. But I thought that these were fun examples from Chapter 10. One, because you guys have already seen these tables, and now this might give you a better idea about why why the tables are structured the way that they are and why they're separated into different tables instead of just being put into one larger table. And there are other reasons for it too. I mean, breaking this down, having each with its own index key makes some data more performant to look up, that sort of thing. But the main reason is to conform to these first three of the normalization rules. And so we start out with something that's very visually easy to read, and we wind up with something that's a lot more complex, but here they are. A lot more complex and a lot more verbose, I suppose. I mean, there's just more structure in general, but it's a lot easier to look stuff up, and it's a lot easier to manipulate your data and to ensure referential integrity, as it's called, between tables. All right, so I have been yakking at you for definitely long enough here. Hope nobody checked out too hard during that. But again, these are straight from the chapter. So when you read through chapter 10, you will see these examples again. And hopefully when you read them, they will reinforce for you and maybe give you a stronger understanding of those. Like I said, do read through the stuff on the other 4. There are 7 normalization forms altogether. But you really, for most gigs, you really only have to worry about these first 3. If you can if you can conform all of your data to the first 3 normal forms, then you're doing pretty good. Not great, not like, I want to make a career out of database administration, great, but you're doing good. Okay, so any questions, pre-reading questions for this stuff off the top of your heads? Okay, very good. There will be a recording. I will get this uploaded for you.